Good morning, dear children. Today we are beginning with our new chapter from science textbook. Chapter number 4 from chemistry, materials, metals and non-metals. Students, every element on this earth is either a metal or a non-metal, or some of the elements have both of the properties of metals as well as non-metals and are called metalloids. So we are going to discuss about those properties as well as how we can distinguish any element from metal and non-metal. Now let's start reading this chapter. You are familiar with the number of materials like iron, aluminium, copper, etc. Some materials have been given in table 4.1. So there is one activity for you all that you have to identify whether these are shiny or dull or whether these are hard or not hard. So when we talk about iron, so it is shiny as well as hard. Similarly, if we talk about coal, so it is dull as well as it is not hard. Similarly, the rest three are your homework question. So now, can you name some materials which are metals? The rest of the materials in table 4.1 are non-metals. Metals can be distinguished from non-metals on the basis of their physical and chemical properties. Recall that luster and hardness are the physical properties. So this thing you have already learnt in your previous class, that luster is a property of shining, and similarly hardness is also a property, and this we have also solved in our table. Now, physical properties of metals and non-metals. So there are two major aspects on the basis of which we can differentiate between metals and non-metals. So first are the physical properties and the second are chemical properties. So here we are first discussing the physical properties. Physical means the appearance. On appearance, how we can distinguish between metals and non-metals. Have you ever seen a blacksmith beating an iron piece or an article made up of iron like a spade, a shovel, an axe? Do you find a change in shape of these articles on beating? Would you expect a similar change if we try to beat a wood log? Let us find out. So there is one activity 4.1 given. You have to take a small iron nail, you have to take a coal piece, thick aluminium wire and a pencil lead. You have to beat them all with a hammer. You have to try to hit it hard, and also every object should be hit properly. Then you should repeat the same kind of experiment with coal piece, pencil, lead, etc. So you need to record your observation. So what do we find? Iron nail is not beatable. Similarly, coal piece is breakable, means it can be broken into pieces. Aluminium wire can be beatable and it can become thin. Similarly, pencil lead also broke. So that is all we have discussed in this activity 4.1. You saw that the shape of iron nail and aluminium wire changed on beating. If they were beaten harder, these could be changed into sheets. So if you beat harder and harder aluminium as well as iron, you see these become more and more thin, but these do not broke actually. If they were beaten harder and harder, they change into sheet. And you might be familiar with silver foil used for decorating sweet. So kaju katli which you eat, actually the coating on it, that is actually silver metal only. You must also be familiar with the aluminium foil used for wrapping the food. The tiffin box in which the food is kept is wrapped by aluminium foil only. The property of metals by which they can be beaten into thin sheets is called malleability. So this is malleability. So those metals which can be beaten into thin sheets are called malleable metals. Aluminium, iron, these are malleable as these can become more and more thin as we beat them more and more. As you have must noticed, materials like coal, pencil do not show this property. So can we call these metals? No, we cannot call them metals. Can you hold a hot metallic pan which is without a plastic or wooden handle and not get hurt? Perhaps not. Why? Try to list some other experiences in which a wooden or plastic handle protects you from being hurt while handling hot things. So whenever we have any hot pan which does not have any handle, so we do not hold it because it is very hot and it can burn our fingers. So if we are not having handle which is either made up of wood or a plastic, that we discuss actually thermosetting plastic, so we cannot handle it. So on the basis of these experience, what can you say about the conduction of heat by wood and plastic? So wood and plastic do not conduct heat, and that's why at such a high temperature also they did not get hot. Their temperature does not rise. You must have seen an electrician using his screwdriver. What kind of handle does it have and why? So let us find out. So the screwdriver which electrician has is actually a special apparatus which is used to find out or to check or analyze the electricity in any given wire. Also, at the same time, it does not give a shock to electrician. Recall how to make an electric circuit to test whether electricity can pass through an object or not. You might have performed the activity with various objects in class 6th. Yes, that is a similar thing. Now repeat the activity with materials mentioned in table 4.3. Observe and group these materials into good conductors and poor conductor. So iron rod or nail is a good conductor of electricity. Sulfur is a bad conductor of electricity. Coal piece is also a bad conductor of electricity, and copper wire is very good conductor of electricity, and that's why in our house the wires are made up of copper. Actually, do you know students, the best conductor of electricity is silver metal. So you might think that why we are not having silver wires, the wires which are made up of silver metals in our home. The answer is because silver metal is very expensive, that's why we do not use it. And copper wire is also a good conductor and it is cheap and affordable. That's why in our houses wires are made up of copper. Although copper is a good conductor than iron, that's why we use wires made up of copper, not of iron. You observe that iron rod, nail, copper wire are good conductors, while rolled sulfur piece and coal piece are poor conductor. Where do you find the use of aluminium and copper wire? Have you seen wires of coal? Definitely not. Why? Because coal does not conduct any electricity. The property of metal by which it can be drawn into wires is called ductility. Now, the another property, first we read about malleability, then we read about conductivity, now we are reading about ductility. So it is actually a property of metals by which we can draw them into thin threads or wires. Have you ever noticed the difference in sound on dropping an iron sheet, plate, a metal coin, piece of coal or floor? If not, you can try it. So we say that iron sheet, metal, coin, these all make a noise, whereas coal and other non-metals do not make a noise. Do you note any difference in the sound produced? Have you seen wooden bells in the temples? Can you give reason? The things made up of metals produce ringing sound when struck hard. Suppose you have two boxes similar in appearance, one made of wood, another of metal. Can you tell which box is made up of metal by striking both the box? Since metal produce ringing sound, they are said to be sonorous. So, as I already mentioned above that the metals produce sound whereas non-metals do not produce any sound, the ones producing sound that are actually metals are sonorous. The materials other than metals are not sonorous. So four properties till now we have discussed: malleability, conductivity, ductility and sonority or sonorous metals. After performing the above activities, we can say that some materials are hard, lustrous, malleable, ductile, sonorous, good conductor of heat and electricity. So these all the terms now you are able to describe in detail. The materials which generally possess these properties are called metals. Examples of metals: iron, copper, aluminium, calcium, magnesium, etc. In contrast, materials like coal and sulfur are soft and dull in appearance. So, they are not considered as metals as they do not have any of the following properties. They break down into powdery mass on tapping with hammer. Now if you try to break a iron, you are not able to. It will get thinner and thinner. That is why it is a metal and it is malleable. And hence coal is not malleable because it broke into pieces. It does not get thinner. They are not sonorous and are poor conductor of heat and electricity. These materials are called non-metals. The examples of non-metals are sulfur, carbon, oxygen, phosphorus, etc. So these four are the non-metals. Means they are not having any of the properties which metals have. Now there is one fun fact. Metals like sodium and potassium are soft and can be cut with a knife. So, sodium and potassium are though metals, but they can be cut with a knife. Mercury is only metal which is found in liquid state at room temperature. So these are exceptions. Science has many exceptions in it. Here we are also discussing some exceptions. We already thought of metals being sonorous, hard, malleable, ductile, lustrous, etc. But sodium and potassium are neither lustrous, they are neither ductile, and first of all, they are reactive as well as they are soft. But yet they are metals. Mercury is liquid. All the metals are hard, but mercury cannot be because it is a liquid. So there is one major difference you can see here, and when you study more and more about chemistry, you find many metals which have exceptions among them, which are yet metals. So that's all for today, students. Thank you and have a nice day.